For most of modern history, spaceflight was something only governments could afford. Rockets were built like ultra-expensive disposable machines, launched once, burned through enormous budgets, and then lost forever. SpaceX entered that world with a simple but radical idea: if reaching orbit could become cheaper, more reliable, and more frequent, space would stop being a rare national event and start becoming an operating environment. That is the real story behind SpaceX. It is not just a rocket company. It is a company built around changing the cost structure of space itself. From cargo missions to the International Space Station, to reusable boosters, to global satellite internet, SpaceX has tried to turn space access from a custom government project into something closer to a repeatable service. SpaceX was founded in 2002 by Elon Musk with ambitions that sounded almost unrealistic at the time: reduce the cost of spaceflight, improve access to orbit, and eventually support human settlement beyond Earth, especially on Mars. But the early company was not a guaranteed success story. Its first rocket, Falcon 1, failed 3 times between 2006 and 2008. Those failures were not small setbacks. They nearly pushed the company into bankruptcy. The fourth launch changed everything. In 2008, Falcon 1 successfully reached orbit, making SpaceX the first private company to develop and launch a liquid-fueled rocket into orbit. That milestone gave the company technical credibility at exactly the moment it needed survival credibility. The next major step was Falcon 9, a larger launch vehicle designed not only to carry meaningful payloads, but eventually to be reused. SpaceX launched Falcon 9 in 2010 alongside the Dragon spacecraft, which was developed to serve NASA contracts for cargo delivery to the International Space Station. This relationship with NASA was crucial. It gave SpaceX a demanding customer, a practical mission, and a way to prove that private industry could perform tasks previously handled mainly by national space agencies. In 2012, SpaceX began commercial resupply services missions and became the first private company to successfully dock with the International Space Station. That moment showed that commercial spaceflight was no longer a theory. It was becoming part of the actual space infrastructure. The breakthrough most associated with SpaceX is rocket reusability. Traditional orbital rockets throw away their most valuable hardware after every mission. SpaceX attacked that assumption directly by developing the ability to land and reuse the Falcon 9 first stage. In 2015, Falcon 9 Flight 20 achieved the first successful landing of an orbital-class rocket booster. 2 years later, the SES-10 mission marked the first reflight of an orbital-class booster. This mattered because reusability changes the economics of launch. Even if refurbishment is complex, recovering and flying the same booster again can reduce waste, increase launch cadence, and make customers more confident that space access can be scheduled regularly rather than treated as an exceptional event. Over time, Falcon 9 became more than a successful rocket. It became the workhorse of modern orbital launch. By May 2026, Falcon 9 launches were averaging roughly 3 missions per week, and Falcon boosters had completed nearly 650 landings and reflights. That kind of cadence is important because launch frequency creates its own advantage. More flights mean more operational data, more refined procedures, more customer trust, and more opportunities to spread fixed costs across missions. SpaceX did not only build a rocket that could land. It built a system where landing, inspecting, preparing, and launching again became part of the normal operating rhythm. That is why Falcon 9 became so difficult for competitors to match. Falcon Heavy extended that strategy into heavier payloads. First launched in 2018 after years of development, Falcon Heavy used 3 Falcon 9-derived boosters strapped together to create a much more powerful launch vehicle. Its design reflected a practical SpaceX pattern: reuse proven components, scale them into a bigger system, and use operational experience to reduce risk. Falcon Heavy gave SpaceX the ability to serve missions that needed more lift capacity, including national security and deep space payloads. But its importance was also symbolic. It showed that the company was not limited to one medium-lift rocket. SpaceX could build a broader launch architecture while still relying on lessons learned from Falcon 9. SpaceX's customer base also reveals why it became strategically important. Its largest customers include NASA, the United States Space Force, and the National Reconnaissance Office. These are not casual clients. They represent civil space exploration, military space operations, and intelligence-related space infrastructure. When agencies like these depend on a launch provider, that provider becomes part of national capability. SpaceX's lower cost and high-frequency launch model made it attractive, but reliability was just as important. Government customers need missions completed on schedule and payloads delivered safely. SpaceX's rise, therefore, did not come only from innovation. It came from converting innovation into repeatable services that major institutions could trust. Then SpaceX expanded beyond launch services with Starlink. In 2019, the first operational satellites of the Starlink internet constellation came online. This changed the company's business model. Instead of only selling launches to outside customers, SpaceX began launching and operating its own communications network in orbit. Starlink created recurring revenue, diversified SpaceX's income, and eventually became one of the company's most important financial engines. It also gave SpaceX a powerful internal customer for its rockets. The company could launch its own satellites frequently, improve the network, and keep Falcon 9 flying at a high rate. Starlink also led to Starshield, a military-focused counterpart, linking commercial connectivity with defense applications. Human spaceflight became another major pillar. In 2020, SpaceX began operating Dragon 2 capsules for NASA and private crewed missions. This was a significant shift because carrying humans is not just another version of carrying cargo. It requires different safety standards, mission planning, emergency systems, and public trust. Dragon 2 helped restore an American crew launch capability and opened the door for private astronaut missions. In practical terms, SpaceX moved from proving it could deliver supplies to proving it could transport people. That transition made the company central not only to satellite deployment and cargo logistics, but to the future of human activity in low Earth orbit. While Falcon and Dragon reshaped the present, Starship represents SpaceX's biggest bet on the future. Starship is designed to be the largest launch vehicle in history, and SpaceX has been building and testing prototypes to push toward a fully reusable heavy lift system. The scale matters because if Starship works as intended, it could carry far more mass to orbit and potentially reduce costs even further. NASA also plans to use an adapted version as a human lander for lunar missions under the Artemis program. That connects SpaceX's private ambitions with America's return to the moon strategy. Starship is still a high-risk project, but it is aimed at a much larger vision than incremental improvement. By 2026, SpaceX had become a company with multiple divisions rather than a single rocket business. Its space division handled orbital launch and spacecraft operations. Its connectivity division operated Starlink and related communications services. Its artificial intelligence division included Grok, X, and data center operations after the acquisition of xAI. The company also announced a joint venture with Tesla to build Terafab, a large semiconductor fabrication plant. These moves suggest a broader strategy, combine launch, communications, computing, and infrastructure into one vertically integrated technology. Ecosystem. That kind of structure can create enormous advantages, but it also makes the company more complex, more powerful, and more exposed to execution risk. Ownership and control are also part of the story. Elon Musk owns 42% of SpaceX's outstanding shares and controls 85% of the voting power through supervoting stock. That means SpaceX is not just founder-led in the casual sense. It is structurally controlled by its founder. This can allow fast decisions, long-term bets, and aggressive risk-taking without the same pressure a typical public company might face. But concentrated control also means the company's direction is closely tied to one person's judgment. SpaceX's achievements are inseparable from its willingness to move quickly, accept failures, and pursue huge goals. The question is whether that same model can scale indefinitely. The larger meaning of SpaceX is that it changed what people expect from the space industry. Before SpaceX, launches were expensive, infrequent, and mostly government-centered. After SpaceX, reusable boosters, frequent missions, private spacecraft, satellite megaconstellations, and commercial crew flights became part of the normal conversation. Its 2026 public offering, reported as the largest IPO in history, reflected how valuable investors believed that transformation had become. But the real legacy is not just financial. SpaceX made orbit feel less like a destination and more like infrastructure. If space becomes cheaper, busier, and more connected, SpaceX will be remembered as one of the companies that forced that future to arrive faster. If you found this helpful, please like this video and subscribe for more explainers.